What is a limit? That is a very important question. And that topic, limit, what we're going to talk about, creates calculus. It's what makes calculus happen. It's the building block. What a limit is, it's basically what you're approaching, or a function is approaching from both sides. It's a value that sometimes you cannot know for sure, but what would it be if you approach from both sides? Alright, so what I'm saying by that is if I have a graph, okay, and let's say I have a hole in it, which is very common to have graphs with holes in them. You might not notice it, but there are holes in some graphs. I do not know the value of my graph at that point. But if I look at what's happening as I come from this way and as I come from this way, can you tell what that hole is? Okay, because right before they both come together, you can tell that value. That's what a limit is. What are you approaching from both sides? Or what does a value of something look like it's going to become? Alright, and here's what it's saying. The limit as x approaches a, some number, from the negative side, okay, from the negative side, or from the positive side. Okay, negative side means from this way, positive side from this way. It's saying that they're equal. If the value you approach from this side is equal to the value you approach from this side, there is a limit. There are sometimes when you have a graph where the value coming from the right or the positive side is not equal to the value you're coming from the negative side. Thus, you do not have a limit. And let me show you 3 situations where the limit fails to exist. Here's one, and it's very common. You might have a graph, for instance, that does this. Okay, there's my graph. It has a break like this. And what happens is, well, the value as you come from this way is going to here. The value as you come from this way is going to here. Do the values from each side go to the same place? No. This is a limit that does not exist because the values that come from the left and from the right, from the negative side and from the positive side, are not the same. There's one example. Another example is called a vertical asymptote. Okay, if you look at a vertical asymptote, you have a graph that might look like this, alright, and then it might go like this. No matter what is happening here, the limit does not exist. Because as you get closer and closer from this way, and as you get closer and closer from this way, they do not approach the same value. Okay, so there is no limit that exists at an asymptote. Alright, that's another very, very common limit because they do not approach the same value. Lastly is this one, which is so uncommon. I don't even really talk about it much. It's called oscillation. You have graphs that can, when you come from this side, they oscillate. Once you get to the point you're looking for, they oscillate so fast you don't have an answer. And when you come from this side, they oscillate so fast, back and forth. Kind of like a heart monitor, EKG is going up and down. Basically, those random, rare situations, you don't have a limit because it's oscillating so fast. What you come from this side and what you come from this side don't agree. I wouldn't worry about this one too much. These are your bread and butter. Alright, something you will run into on this one is, yes, this one does not exist, but sometimes what happens in the future is you could have an asymptote, say a vertical asymptote. If your graph looks like this, it's going to be kind of weird, you're going to run into this. If your graph, both sides of the vertical asymptote go up forever. Well, yes, they don't approach the same value, but this one, what they'll say is, well, if they're both going up to infinity, to the same infinite direction, you can say the answer is infinity. It implies there is no limit because they don't go to the same value, but infinity tells you they're going up together forever, which implies something and tells you something. So in this situation, you would have a limit as x approaches whatever this asymptote is, would be infinity. Okay, if they both went down, it'd be negative infinity. But when you say negative infinity and positive infinity for limit answers of limits, it doesn't really exist because you're not approaching a value. What they go and equal, they do not actually equal each other. They're approaching infinity, but they're not equal to each other with this one. So be aware, you will run into this later. If they both go in the same direction, you can call it infinity if they both go down negative infinity. But basically they do not exist, especially when they go opposite directions. And this one, they just don't approach the same value. Alrighty. Now, how do we find limits? Well, one way is you make a table of values. And here's what I mean by that. You make a table like this. Okay. You go Alright. Let's say we want to know as x approaches, let's say we're taking the limit as x approaches 2 of f of x. Okay, x approaches 2. So what we do is make values from both sides. Alright, we're going and trying to approach 2. So what's a value right next to 2? Well, that would be like 1.5. I could put in 1. I can put in 0. Okay, do you see how we're approaching 2? And from this side, I'm going to put 2.5, 3, 4. Do you see if I fill this table out? Alright, aren't we approaching right here? Okay, that's what we want to find. Now, we don't, if we did this table, we did it from both sides, we can see what value we are approaching and get an approximate value of a limit sometimes. Alright, so that is one way, tables. Okay, again, you just have to put a whole bunch of values into the function until you find what it looks like it's squeezing to. The other way is, if you have a graph, look at the graph. For instance, if you have a graph that goes like this, alright, and then it goes like this, well, you can look at your graph and see what are we approaching from both sides. Okay, well, this right here, that's where we're approaching. So you can technically just look at the graph. Alright, now here's what's going to be funny is sometimes you'll have a dot down here, you have a hole, but a dot down here. Well, the limit is where this dot is. The value is that blue dot. It's kind of weird. You'll see these functions that do this, these piecewise functions. So the limit is this open circle, but the value is the blue. But basically, if you have a graph, you just look at the graph. What are we approaching from both sides? That's another way. And the last way, and most common, is the analytical, also known as algebraic. There's two ways, analytically, algebraically, two different names people use for it. And that basically means is plug the number in. If I have a function, if I want to find the limit as x approaches 2 of f of x, well, you just plug in 2. Plug in that value and see what happens. Okay, if that doesn't work, then you're going to have to do some factoring, canceling, to try to rewrite the function and then try to plug in the value 2. So basically, again, when you're trying to find a limit, algebraic or analytically, you're going to plug in this value. If that doesn't work, you're going to do something to the function and then try to plug in the value. Okay, this again is the most common, is the best. These are good if you have the tools. This is a last-ditch effort. This actually, you don't want to do this usually. This is very good if you have a graphing calculator or if you have the graph available. Okay, two ways, most common, you don't have a limit. This one probably would never run into it. And what is a limit? It's what we're coming to from both sides. The negative here means from the negative side. The positive here means from the positive side. And this limit idea is what created calculus. It's what made calculus come to play. It's a very important concept.